Hello students, today we are starting the new chapter of ray optics, and it will have more than 10 lessons with few parts in each lessons. The structure of this chapter or unit will be that we will understand the core concepts first, and then after every lesson you will find some of the problem solving sessions as well. There are a large number of lessons in this chapter or unit, and I would like you to brush up some of your knowledge about light from that you have studied in your previous classes. And that is what is light, although we are going to talk a little bit about it, but it will be really helpful if you revise a little bit. What is light, what are mirrors, what are lenses, what are the rules of image formation, and all those things. Definitions associated with mirrors and lenses. All these things are there in your curriculum. But if you have a little bit of revision from your previous classes, then it will really help us to grow from there. So today's learning objectives are to understand reflection of light, and then quickly we will move to spherical mirrors. This is the first in the first teaching topic. We will only take up reflection of light and spherical mirrors. And in the second part, second teaching point, we will derive the mathematical formula for mirrors, spherical mirrors, and which is known as mirror formulas. After the lesson, I expect that you will be able to really understand and gain knowledge about what is reflection, which type of mirrors are used for reflection, what are images produced by mirrors, and then you should be capable to derive and draw diagrams and then derive the formula. So a lot of skills enhancement is there in this particular lesson. Now, as we all know that light is a form of energy, and we have just studied that light, or rather we are going to study later on that light is having a dual character. It is particle nature and it is wave nature. And I hope that you understand what is the meaning of wave. Wave means disturbance created in space, in a region. Space always does not necessarily mean that it has to be vacuum, and it has for it to experience you have to go outside the earth. It is not like that. Space is all the space which is available to us, even at the surface of the earth or anywhere else in the universe. So if there is an energy disturbance, then it is called wave, and light travels from one part to other part in space with the help of these disturbances, which are called wave. There is another theory which suggests that light is a stream of small particles called quantas, and so light can be treated to be as particle and wave both. One more thing, light travels in straight line. We all know that. And when it hits a boundary, what is the meaning of boundary? Boundary means there is a distinct layer about which there is difference in the medium. It can be air and glass, it can be air and water, glass and water, vacuum or air or anything. So there is a distinct demarcation surface about which the media are different. So it hits to bounce back. Then the phenomena is called reflection. So this is about the reflection, and the scientists studied a lot on this phenomena of reflection about a boundary, and they came out with laws. Laws of reflection. Now for laws of reflection, we have to take a boundary, a surface, a plane mirror. A plane mirror is shown like this, as we all know, because we have been doing this reflection a lot in our lower classes. This is a light ray, a single very sharp beam of light. If it is extremely sharp, pinpointed kind of, then it is called ray. And if it hits at this point, this is called point of incidence. And then it reflects. So we draw a normal at the point of incidence, and we all know that this is angle of incidence and this is angle of reflection. And we all know that there are two laws of reflection. The first law is incident light ray reflected light ray and the normal lie on the same plane. And here in this case, the plane is the plane of the paper. It is not that the dotted line, which is the normal, the incident light ray which is incoming, will lie on the plane and the reflected ray will come out of the paper or go inside the paper. No, it is not that. It will always lie on the sheet of the paper or on the screen where I am drawing the diagram. So all three has to lie in the same plane. So that is the first law. And the second law, we all know it is a mathematical law, and which says angle of incidence I is equal to angle of incidence R. This is the boundary which I am talking about. And this boundary has been shown to have this surface as reflecting. This surface is called reflecting, and this surface is called polished. You must have seen that there is an orange paint at the back of the mirrors, or at times it is gray also. If you scratch a little bit, you will find that the orange paint comes out, and beneath it there is a silver foil which is pasted on the glass sheets. The silver foil at the back of the glass sheet makes light reflect, because silver is a very shiny metal. It has luster, which is called the reflecting. If the reflecting is much more, it has a shine. So that foil is pasted, and to save that foil, iron oxide is painted, which is of red color. And so one side is polished, the other side, glass side, becomes reflecting. Now, this boundary can be a plane and it can be curved also, right? So if it is a curved surface, then it can be a part of a curved mirror. right? Now curved mirror are of different types. We will talk about that a little later, but we have to pay attention to only spherical mirrors. So the curved mirrors that we will talk about are the spherical mirrors, and therefore we pay attention to that. Spherical mirrors are produced by cutting out a part of a hollow glass sphere. So suppose we have a glass sphere which is indicated in this manner, and we try to cut out a small part from the surface. This can become a spherical mirror. It can be a circular patch also. It can be a rectangular patch also. That doesn't matter. The outer shape doesn't matter. What matters is whether it has been cut out from a big hollow glass sphere or not. Any part which is taken out from such glass spheres will form a spherical mirrors. They are of two types. If the bulging side is polished and the inner side is reflecting, then it is called a concave mirror, right? And if the inner side is polished and the bulging side is reflecting, then it is called convex mirror. So this is the difference. One side is reflecting, the other side is polished. So if the inner side is polished and the outer side is reflecting, then such a mirror will be called convex mirror. And if the outer side is polished and the inner side is reflecting, then it is called a concave mirror. So you have to understand these structures. These are the two types of spherical mirrors that we are going to discuss, and we have to find out what are the quantities involved or related with such kind of mirror. So the first thing is that we call is the definitions. And the first definition is the pole. Pole is a point which is the geometric center of the mirror. Now suppose this is the mirror, right? This is the reflecting side, the outer is the polished side, and so this becomes a concave mirror. The center of this structure, so the outer periphery is circular, suppose. This point which is right at the center is called the pole. Second definition is center of curvature. Center of curvature means the center of the hollow sphere from where the mirror is taken out. Now, if the mirror is a part of a big circle, or rather big sphere, since I told you this part is taken out and it becomes a mirror. Now, this belongs to a big sphere. The center of that sphere is called the center of curvature. And this is denoted by capital C. Pole is denoted by capital P. Let us see other definitions. The third definition is radius of curvature. Radius of curvature is the radius of the hollow sphere from where the mirror is cut. So the big sphere has a center, and from the center to the pole, that is the radius of the hollow sphere. Right? This is the mirror. This point is the pole, which is on the mirror, and there is a center of the hollow sphere, which is somewhere here. The distance between these 2 points is the radius of curvature. So it has two definitions. We can also write distance between pole and center of curvature. This is also the definition. Radius of curvature is denoted by capital R. Fourth definition is principal axis. It is an imaginary line passing through pole and center of curvature. So the imaginary line which can be assumed to be passing through the center of curvature and the pole, that line is principal axis. You have to imagine that there is a line which is existing, and that line meets the mirror in a perpendicular direction, because this is nothing but the diameter or the radius, and radius will always meet a point on the circumference at 90 degree. So this is perpendicular, right? So you have to understand all these definitions quite clearly, because there are many 1-mark questions or even MCQs at times asked on these definitions. Principal focus. It is a point on the principal axis where all light rays parallel to the principal axis meet or seem to come from. So there is a point on the principal axis where if all the light rays which are parallel to the principal axis after reflection from the mirror converge for a concave mirror. But for convex mirror, all light rays which are parallel to the principal axis will diverge, and if we receive those diverged light rays, we will feel that as if those diverged light rays are coming from a point on the principal axis, and that is why the word seem to come from. So for convex lens, they seem to come, for convex mirror, they seem to come from, and for concave mirror, they are actually meeting. So that point is called focus. Focus is denoted by capital F. 6. Focal length. The distance between pole and focus is called focal length. It is denoted by small f. And 7th is aperture. The cross section visible to all light rays is called aperture. Aperture means what is the entire area that is available to us or to the light rays to fall. So if I say that this is the lens, then this aperture is a rectangular area. If I say that we take an ordinary small concave or convex mirror, we see a circular patch. That circular patch is called the aperture. So these are the definitions. And then now we go to the sign convention, which is very important. Now you have to understand the sign convention properly, because what does mirror do? They produce images, and they will produce images if objects are kept in front of them. And that is why for mathematical clarity, to draw images, we need to place the object at a certain position. And therefore we require sign convention, where to keep in front of the mirror, how much distance, and so on. So we need a sign convention, and the sign convention is the mirror is kept such that the pole coincides with the origin in Cartesian coordinate. Cartesian coordinate is nothing but the XY system. And so in diagram, if this is the y-axis and this is the x-axis, suppose I have to keep a concave mirror. I will keep the concave mirror in this way, so that the pole, which is denoted by this point, coincides with the origin. And therefore, this is nothing but the origin. This distance is positive. This distance is negative. Up distance is positive. And down distance is negative. So the mirror has been kept like this. And if I have to keep a convex mirror, then I will keep in this way. Right? This is the pole. This is the polished side, and the front side will be reflecting. Remember, I have drawn this diagram intentionally in such a way that the reflecting side is on the left and the polished side is on the right. In ray optics, it is extremely important that you follow the sign convention. If you don't follow the sign convention, then problems, numericals will throw wrong answers, and you have to be very, very careful about it. After this is the pole. If I draw this entire sphere, then somewhere here will be the center of that sphere from where the mirror has been cut. So this is the center of curvature. Focus is exactly at the midpoint of C and P for spherical mirrors. So this is the focus. The distance from C and P is the radius of curvature. Distance between F and P is the focal length. Right? So in this diagram, it is very clear that which points correspond to C, capital F, capital P, and what are the distances R and F. If you notice, the radius of curvature for concave mirror is on the left. So starting from pole, if we measure something on the left, it is negative. So we will have negative R value, and similarly negative F value, because it is also on the left. Whereas if you see on the other diagram, the sphere will be on this side. The center of curvature will be somewhere here. The focal length or the focus will be here. So R is positive and F is also positive. This is the sign. For concave, both are negative. For convex, both are positive. Remember this. This is extremely important. Now, how do we draw images? And for images, there are rules. There are 3 rules, and they are called rules of image formation, or 3 important light rays. And we are going to talk about these 3 important light rays. Pay attention. Number 1 rule. Rule 1. In rule 1, and we are taking only one mirror, that is concave mirror, but the rules are true for both the mirrors. this is the principal axis. Rule 1 says this is the center of curvature and this is the focus. Any light ray which is parallel to the principal axis after reflection will pass through focus. This is the focus and this is center of curvature and this point is pole. Any light ray parallel to the principal axis after reflection becomes, or after reflection, passes through focus. This is rule number 1. Rule number 2. Any light ray which is passing through the focus after reflection becomes parallel to the principal axis. It doesn't look like parallel, but I am drawing it again. Becomes parallel to the principal axis. Any light ray passing through focus after reflection becomes parallel to the principal axis. And rule number 3 is any light ray which is passing through center of curvature will bounce back in the same path. So any light ray passing through center of curvature bounces back and retraces the same path. Retraces the same path. So these are 3 rules, and we have to now see the image formation and then derive a formula which is called the mirror formula. And for mirror formula, we have to understand what are the quantities involved in that. So firstly we will do that and then derive the mirror formula.